Elementary Algebra, Final Assessment 3, Review, Questions 1 through 7, Outcome 1, Graphing. Graph the equation. In question 1, we're given 2x minus y equals -6. To graph the equation, we're going to need to find at least 2 ordered pairs to create a line and a third to check our line. To do this, we're going to look at our equation and select random numbers to plug in for either x or y. Only suggestion in selecting these numbers is to look at numbers that will make the math simple. For example, zeros, ones, and twos. Or, if fractions are present, use values that will help you clear the fractions easily. In this problem, I'm going to choose x as equal to 0. Now again, this is just a random number I've selected. I chose 0 because it would make the math simple. I'm going to come back and plug in to my equation everywhere I saw an x, a 0. So I'm going to have now a 2 times 0 minus y equals -6. I'm going to continue on to solve the problem. 2 times 0 creates a 0 minus y equals -6. So now I want to clear this negative sign off the front of my y. What I don't see in here is that there is a 1 in here. So this is a -1 being multiplied to my y. So to clear it, I'll divide by a -1. I'll do this to both sides. This clears my -1, leaving my y equal to 6. So my first ordered pair here will be my x and my y, which are 0, 6. This will be my first ordered pair graphed onto my graph. But before I graph that, I want to find 2 more points. So I'm going to go ahead now and select a 1 for that x. So I come back here and I plug a 1 in. I'm going to have 2 times 1 minus y equals -6. Well, 2 times a y equals a 2. So I have a 2 minus a y equals -6. Now I'm going to subtract the 2 off both sides to clear it from the left-hand side. So this goes down to 0. It's now a minus y equals a -8. And just like the other one, I'm going to divide now by a -1 so that I clear out that negative sign again. So when I look at it, I come out with y, and I'm going to shift over just a little bit here, as y equal to a +8. That's by taking the -8 and divided by a -1. So my second ordered pair now will be 1 for the x that I selected, and then I solved to find y is equal to 8. Now I have 2 ordered pairs. 2 ordered pairs will create a line, but I want to be able to check my line when I'm done. So I'm going to come down and I'm going to do this math problem one more time for one more number. This time I'm going to say that x is equal to a -3. So I'll plug that in. So 2 times a -3 minus y equals a -6. Now I can come back and multiply this through. So I have 2 times -3 as a -6 minus a y equals a -6. I'm going to add a 6 to both sides to clear it off the left side. So +6 +6. As I do this, this comes down to 0. I still have the minus y to carry down, which then gives me on the other side a 0. Well, I want to clear that negative by dividing, so I will come back in there and divide by that -1, but 0 divided by a -1 is still 0. So my last ordered pair ends up being -3, 0. I need to come up and graph these onto the graph above. So I'm going to kind of scroll up here just a little bit. Okay, so now I've actually scrolled back up to the graph, and I'm going to put those 3 points or ordered pairs that I've just identified onto my graph. My first one was 0, 6. 0 being in the x position, so it's telling me whether to go left or right on my graph. Well, with a 0, it means neither go left or right, just to stay at the origin or the center. The next number, the 6, is in the y position. This number is going to tell me whether to go up the graph or down the graph. If it's positive, I move up, and if it's negative, I move down. So in this one, it's a positive 6, so I'm going to count up a positive 6 and put my point. 1, 2, 3, 4, 5, 6, and I can put my point onto the graph. So now I have a 0, 6. And I'm also labeling my point. It's very important, just like with your number lines before, to label anything that you place on the graph. All right, now next, I'm going to go ahead and put my 1, 8 for my second problem. So that 1 is telling me, since it's positive, I want to move along the x-axis at one place to the right. Now I want to move 8 places up because it's positive along the y. So 1, 2, 3, 4, 5, 6, 7, 8, and place another dot. So now I have a 1, 8. I'm labeling it again. Now these two would actually create a line for me if I were to start to draw one in. I'm going to go ahead and put my third one in here, and I want to see if all 3 line up on a single line. So my last one was a -3, 0. So that -3 tells me to move out to the left 3 places, 1, 2, 3. And the 0 means I'm going to stay. I'm not going to move up or down from that -3. So I'm going to put my dot on there. So I have a -3, 0. And if I actually look at these points here, I can see that all 3 can line up on the same line. Now, if you attempt to graph your points and you find that when you place your line in, all 3 points do not graph on the same line, this is indicating that you've made an error and you need to go back and check your math. All right, now we're ready for question number 2. In these instructions, it says to graph using the x and the y intercepts. We're given the equation y equals 7. Well, in this case, we don't have an x value. This also means that we won't have an x-intercept. If we remember from page 254 from your textbook, there's a rule for horizontal lines. It says the graph of y equals c. So in this case, if we look back, we have a y equals 7. So our c is a 7. Where c is a real number constant, is a horizontal line parallel to the axis that passes through the y-axis at a point with coordinates 0, c. So in the case of our problem, which is y7, our coordinates are going to be 7. So we're going to come back up, and at the point where we see 0, 7, we're going to graph a line. So we're going to start at the origin. The 0 means we don't move left or right, but the 7 means that we move up 7 places along the y-axis. So 1, 2, 3, 4, 5, 6, 7, and we put our point. We go ahead and label our point 0, 7. Now we also know that our line is going to be a perfectly horizontal line running right through that point. So now that we have our point on, we can put this perfectly horizontal line right through it. And we've completed our exercise. We have graphed using the y-intercept. In question number 3, we're given the instructions: determine the slope and the y-intercept, then graph the equation. We're given the equation y equals a -4x plus 6. This is what's called our y-intercept form, also known as our slope-intercept form, where we see some value given as y equals mx plus b, where the m represents our slope value And the b, when placed in the ordered pair with a 0, so 0, comma b, represents our y-intercept. So looking back at our equation, we know that our slope is going to be a -4 because a -4 shows in the m position, so -4. We also know that our y-intercept is going to be 0, 6. Knowing this, we can now graph our y-intercept directly onto our graph. So we'll start at that 0, and we'll move up 6 places, 1, 2, 3, 4, 5, 6, and we're going to put our dot. So we have 0, 6. Next, we want to continue and get a second point. We can do this by using the slope, we can do this by using the slope and using it as a rise over a run, which I'll show in a moment, or you can also return to the same procedure you used with question 1, where you randomly selected values to plug in for either your x and y and solve for the second. But let's use this different one. It's a little different from what we used in question number 1, and that is using the slope. We know our slope to be a -4. If we put that out over 1, we now have it in a fraction form. Slope is also known to be the rise over the run for a line. So if we were to come back to where we see our first point graphed, if we use the -4 as our rise, so this means a -4, instead of actually rising 4 places, we're going to drop 4 places because it's negative. Drop down 4 places, 1, 2, 3, 4, and then we're going to move over 1 place to our right because it's a +1 right below that -4, 1 place, and put our dot. When we read it off the graph, we see this is going to be 1, 2. We can just read it right off the graph. From the origin, it comes out 1 place, 2 places up. So this is actually giving us a point. We can continue on using the same method. I'm now going to start at the new point that I've created and drop down 4 places, 1, 2, 3, 4, and then I'm going to move over 1 place. I can see now that I'm actually at the 2, -2. I can label it. Now that I have these points, I can place my line through my points, and I've graphed the line as the second part of the instructions direct you to do so. You have the option here of using rise over run to graph your line, or you may go back to what we did in question 1 and plug in random values and solve for the other unknown to find ordered pairs. For question number 4, we're given the same set of instructions. Determine the slope and the y-intercept, then graph the equation. This time we're given an equation that is in what's called standard form. Standard form is whenever we see something in the form ax plus by equals c. So our problem 2x minus 3y equals 10 is in standard form. Before we can find the slope in the y-intercept, we need to get it into the y-intercept form or slope-intercept form, which is y equals mx plus b. So we're going to rewrite our problem over here, 2x minus 3y equals 10, and work towards isolating the y. We'll do this by first subtracting the 2x off both sides. This clears the 2x from the left side, leaving us only with a -3y. On the other side, we have our 10 minus 2x. We can't combine this 10 and the 2x because they're not like terms. Now, I'm going to, before I continue, kind of flip the position of these. I'm going to put this -2x in the front and the plus 10 to the back. We can do this because of the commutative property, right? In the commutative property, it doesn't matter what order we sum these in. that's going to create the same value, so we can change their positions. Now I'm going to get rid of the negative 3. So I'm going to take that negative 3 and divide it out to everything. Clears it off the left-hand side, so we're left with y is equal to 2/3 x minus 10 over 3. All right, so now I know my slope. The instructions asked us what our slope was. Our slope is what is given in the m position as 2/3. Our y-intercept, which is something that we're also asked, comes from the b position, and it's going to be 0, negative 10 over 3. Now we're ready to come in and graph our point. So starting at the 0, right, we're neither going to move left or right because it's 0, but we are going to move down. This is a negative 10/3, which would also be the same as a negative 3 1/3. So we're going to come down 3 places, 1, 2, 3. Then we know that we're going to come down about 1/3 of the way down, not quite touching the next point. All right, so we're going to label our line, our point, as 0, negative 10/3. If we use the method that we learned previously, the rise over run, our rise would be 2 positions up, so 1, 2, and then 3 over. 1, 2, 3 to place another dot. So I just rose 2 places and came over 3 places. Created my next point, and now I've created 2 points and can create my line. Question number 5, same instruction as before. Determine the slope in the y-intercept, then graph the equation. So we know that our slope is going to come from our b position. So our slope, excuse me, not from our b position, but our m position. So our slope is equal to a negative 1. Then our y-intercept will come from our b position. Our b position has a negative 5, so it will be 0, negative 5. Now we can come down here to our graph and put our point on. So we'll start at the 0 and come down 5 places, 1, 2, 3, 4, 5. Place our dot, label it 0, negative 5. Now we can come in and place some other dots by using the rise over run. Now with this one, we have the negative sign. So we can choose to put the negative on the 1 or the top position or numerator's position and the positive 2 on the bottom, or we can rewrite this so that we put the negative on the bottom position or the denominator's position so that we have a 1 over a negative 2. But we do have to make a decision. Do we want to put that negative on the top or the bottom? So now we're going to have in this one a rise that's negative, meaning we go down instead of up, and a positive run, which means we'll be going out to the right. On the other one, however, we have a positive on the rise, so we'll move up, and a negative on the run, so we'll move left. So let's try this out. So I'm going to start with the first one, where I have a negative 1 over a 2. Well, according to this, the negative 1 is my rise, but a negative 1 instead of rise means go down. So I'm going to come down 1 place, but then run out 2 places to the positive. That gives me a point here. I can do the same going the opposite direction with the second one, where I rise 1, positive, but run to the negatives 1, 2. You can see how it comes out in line just on the opposite side. Now I can put in my line, and now I've graphed my line. In question number 6, we're asked to write the equation of the line in a slope-intercept form. So we're given a graph that looks like the one shown here on the screen, and we're asked to write this equation for this line. Well, we know that the slope-intercept form is going to be y equals mx plus b. So the two things we need to identify are going to be the slope, or m, and the b, which is going to be the y-intercept. So if we come down here and look, we see that our line is intercepting with the y-axis right here. So this is our y-intercept. So we'll count it and see where it lies. It's at 1, 2, 3, 4, 5, 6, 7. So it's at the -7. So our y-intercept is at 0, -7. So we've identified our B position as a -7. Now we need our slope. We can find this by using the rise over run method. We'll work with the point. We'll find two places where our line is intersecting perfectly, right? With some given lines. We don't want to pick something that's in the middle because it's hard to actually discern where that line is ending up. If I pick this point here and where my line actually crosses the y-axis, I know I'm exactly on an even number with, excuse me, not an even number, but I'm exactly on a whole number. All right, so I start here and I'm going to run up, rise, and if I look at this and I rise up to the top, I'm actually going to rise 7 places. Right? My line went a little crooked there. Let's try to straighten that thing out. I'm actually rising 7 places. And then to run over to my dot, I'm actually running 2 places, but I'm running to the negative 2 places, or to the left. Let's fix that. Let's rise 7 places. All right, so there's my rise over run. I find that m is equal to a 7 over -2, or simply a -7 over 2. So now I can plug these back into my problem, or into my slope-intercept form. So I have a y equals a -7 over 2x minus 7. And there is my equation. In question number 7, we're asked to write the equation of the line in slope-intercept form. So again, we're asked to write it in the form y equals mx plus b. In the case of this line, we're actually given a perfectly vertical line. It's straight up and down. We actually do not have a y-intercept. But what we do have is an x-intercept. We have x intercepting here at 0, oops, little error there, at -5, 0. If you remember from your book, anytime that you see a vertical line, it's going to be represented as x equal to a c value. Well, in this case, our c value is where our line crosses the x-axis. So x is equal to -5. This is our final equation.